Hello guys, this is me Roshan Kumar Shah and I welcome you to my 5th QBasic programming language tutorial. In this tutorial I am going to teach you guys about so-called Armstrong number. Yeah, you heard it correct. It is called Armstrong number. So before starting the tutorial, first of all I would like to say you guys that what the heck is this Armstrong number. By listening to it, it feels that the number must be strong, but by just let's mean it wrong way, then it means that the arm of this number is very strong, as the number says that it is arm a strong number. Just to put a little bit space over here, not there buddy, over here, then it means arm a strong number. It means that such number which has a very strong arm are called Armstrong's number. Well, that's the most deadly concept and it is totally incorrect. Actually, Armstrong number are those numbers. Let me make you guys understand with an example. As for example 153, I'll learn for this example. Now 1 to the power 3, sorry, not exclamation sign, 1 to the power 3 plus, where is the plus sign over here, 5 to the power 3, cool, plus 3 to the power 3. If the sum of the cubes of the each digit of the number is exactly same as the given number, then such number is called Armstrong number. You heard it correct, and this is, I am not joking this time, and this is the correct one. As for example, if you will cube 1, then you get 1. Okay, cool. And it is equal to, if you cube 1, then it is 1, plus if you cube 5, then it is 125. Trust me guys, I am very good at mathematics, and the cube of 5 is 125. Yay, I am a great mathematician that I know the cube of 5. Wow, amazing. And similarly the cube of 3 is 27. Now if you add it, all these three numbers, then what is the output or the result? 153. So just add it. I am waiting for 5 seconds in this tutorial and add this up. Don't trust me, check it by yourself. So your time is up, and I trust you guys that you must have checked it, because if you want to get more and more of knowledge, then do everything by yourself. Cool. Now such numbers in which the sum of cubes of each digit of the number is exactly same as the number, then that number is called Armstrong number. I also have learned some more Armstrong numbers, like what was that, 370, yeah, and even 371 is also an Armstrong number. Both are the consecutive numbers and both are Armstrong number. So this was the concept, that what the heck is Armstrong number. And now in order to get what this program has done, actually it will allow the user to input a number, and this program will check that whether the inputted number is Armstrong or not. So here we go, let's start the tutorial right now. Here enter a number. The user inputs a number and the QBasic will store that very number in the variable called n, and I have said this is step too much time. Now we have the number in a variable n. Now we choose a new variable called p and also assign the same number in p. You guys will know that why I have done so. So we have two variables p and n, and both of them have the values whichever the user has inputted. Afterwards let s is equal to 0. I will also say that I will clearly specify that why these two statements have been written in the program. These are very important but I will say its importance or that why it has been mentioned in the program just after 2 minutes. Then only you guys will be able to get it. The most brainy part of the program is this do while loop. It says that do only when n is positive, that is n is greater than 0. Leave over here. These three statements are the brainy part. So let r is equal to n mod 10. Let's take an example. Okay, we will take 153. Okay, as we know that it is an Armstrong number, as 1 cube plus 5 cube plus 3 cube indeed is equal to 153. So let r is equal to n mod 10. Now I have mentioned what is the purpose of using modular sign, and I hope you guys must have remembered those. Mod, it just what gives out the remainder, this n mod 10. And if you will divide 153 by 10, then what is going to be the remainder? Correct, 3. So we have the last very digit of the number, and that is 3, and we have stored. And since wait a second, I will make you guys understand this one very clearly. Here is 153, cool. Now let p is equal to n, and what is n? N is also 153. Let s is equal to 0. What is the value of s? It is 0. Do while n is greater than 0. What is n? N is 153. Then is 153 is greater than 0? Yes, true it is. So write T for true. And r is equal to n mod 10. That means r will store the remainder when the number n is divided by 10. And when the number n, that is 153, is divided by 10, then the remainder is going to be 3. So r will store the value called 3. Now s, new s is equal to old s plus r to the power 3. Now what is old s? Old s is 0 over here from here. And what is r to the power 3? The r, which is r is 3, then 3 to the power 3 is 27. So the new value of s is gonna be 27. And I also hope that you guys must have remembered that what this backslash touch, actually it removes the what numbers digits, or better to say it removes the stops just after the decimal point. As for example, if there is any digit or number after the decimal points, that is to the right of the decimal points, then it forgets those and print out only the numeric part which is in the left hand side of the decimal. So when we divide n, what is n? N is 153, and when we divide it by 10, then it should be 15.3, but since we divided it by using a backslash, so it is gonna ignore 0.3 and the result is 15. Now it will read loop. So if the QIC will read that, oh my god, I have to leave loop, then it is gonna jump up to here again. Now is n is greater than 0? What is n? We have n as 15. And is 15 greater than 0? Yes it is. So it is again gonna be true. Similarly after that, r is equal to n mod 10. What is n? N is here 15. Now the value of n has been changed because we are only looping in this loop. We are just running in this entire loop. We now don't have any meaning of this n, as this is the n which is out of the loop and we already have used it, and we will use the variables or the numbers only from this, as we are looping in these statements only. We have these statements only in control. So let r is equal to n mod 10. What is n? N is not 153, n is 15. So what is 15 mod 10? 15 mod 10 is 5. As when we divide 15 by 10, then the remainder is going to be 5, and modulus does the same work. It gives us the remainder. Now what is the new value of s? New value of s is equal to old value of s, and what was old value of s? It was 27. So new value of s is gonna be 27 plus r. What is r? R is now 5. So it is new value of s is equal to 27 and plus 5 to the power 3, that is 125, and 125 and plus 27 is 152. That's why I said that I am good at maths. Okay, cool. And when we backslash it, what is n? N is 15. So when we backslash it, then it should have been 1.5, but point and the 5 will be neglected. So it is very good. Now n is just 1. Now is 1 greater than 0? Yes. So this will be again true. A better capital true. Now what is the remainder when we divide 1 by 10? It is 1. So it is 1. Now it is, and when we add, the value of s changes to 153. And how is that? Because the cube of 1 is 1 and the previous value of s was 152, so it is 153. And finally now now when we divide 1 by 10, it is 0.1, 0.1. Okay, now 0.1 is gonna be neglected, and the only stuff what is left with us is 0. Now is 0 is greater than 0? No, we got the false, as it is false. So whenever it is false, it just comes out of the loop and execute the coming statements. So is s is equal to p? What is s? We have s as 153. So if 153 is equal to p, now what is p? We have over here p is 150, and the value of p is also 153. So is 153 is equal to 153? Yes, it is. So it prints out that the number is Armstrong. Cool. Otherwise it would have printed that the number is an Armstrong. So this was the very concept. Now as I promised you guys that I will say you, oh shit, I think I did some terrible mistake over here. I shouldn't have done so, but I must have to delete all these stuffs, and then only you guys are gonna run the program, because these are the stuffs which we understand, but QBasic doesn't. These statements are enough for the QBasic to understand. So now why we did s is equal to 0? Actually here the statement let s is equal to s plus r to the power 3, then when we loop it at the first time, then it must take the initial value of s as 0, and that's why, otherwise things are gonna be very worse. That's why I used over here that the initial value of s should be 0. And now why the heck have I assigned the same number to n as well as p? Because when we execute these various statements, then the value of n is not greater than 0. It has changed. Then for comparing over here, we can't use the variable n, and that's why we use the variable p. We needed the same number, but we can't use the variable n. Why? Because we have changed it by doing these steps. N is equal to n backslash 10, and now it is worthless to use n for the comparison over here, and that's why. But we needed the number whatever it was assigned to n, and that's why we assign the number to p also, so that